Hi, I'm Dr. Jones from Central Connecticut State University, and I am uploading a video for my students about fractions. So students, you know we're working on fractions now. I've already uploaded some textbook pages to talk about early concepts of fractions, and also a PowerPoint to talk about the types of models that we can use for fractions. For instance, we have pattern blocks that we can use as a region or area model. We also have color tiles, and you'll use those in your lessons that you do at home. If you don't have any at home, you can go online and you can look up pattern blocks and color tiles. Now the next type of model is the number line model, which is a measurement or a linear model. So we have number lines, and we also have fraction strips that we'll use today. There are other models in your PowerPoint, but I'll just be talking about two models for each. And then for discrete models, we won't actually do discrete models today, but discrete models just means that the items are separated. For instance, a plate of cookies. So each cookie is its own thing. It's a cookie, but I could also have a fraction of the cookies on the plate could be peanut butter. So I might say half of the cookies on the plate are peanut butter. So discrete models are usually real life items like a set of trucks on the floor. And so we could use those. Those are really nice to use for fraction models. But let's go to the board to talk a little bit about some of these models. So the first example that I give is build a rectangle that is 1/3 blue and 2/3 red with color tiles. And so with my color tiles, and I already have this set up, but I would give students a whole set of color tiles and for them to play with first and then for them to use. And so I already took out 3 because I know I want thirds. Now students, when they're first learning this, won't know that. They might just be in the first or second grade. I'll say second grade. And so I took out 3, and it says I want 1/3, 1 out of the 3 to be blue, and 2/3, 2 out of the 3 to be red. So I have them first use the color tiles, and then I have them actually color it in on their paper. So one set could be blue, or one of the tiles blue, and 2 of the tiles red. Now I don't tell them how many tiles to use, because depending on the student, they may already know a little about fractions. And so there might be another student that chooses to do something like this. So they're playing around with their color tiles, and this is what they end up with. And then they color it in. I'm doing it semi-fast, so it's not very neat. And so, depending on the grade level, one of the ideas that you can come to when you're looking at something like this, you can say, how do you know that 1/3 is blue? And I would expect the student to do something like this, whether they're pointing it out with their finger or taking another marker and circling it. I would expect them to say, well, I have 3 parts, Miss Jones or Dr. Jones. I have 3 parts. 1 of the parts is blue, and 2 of the parts is red. So 1 out of 3, 1, 2, 3. So I'm looking at the rows. 1 row out of 3 rows is blue, and 2 rows out of 3 rows is red. So although I have a different number of tiles for each of these, and that's what I'm hoping to see as I walk around the classroom. So as you walk around the classroom and there's somebody, a student looking at another student, and they say, oh, hey, you got something different. And then you could ask, well, I wonder if you can have more than one model that shows 1/3 blue and 2/3 red. Now, if they're in 3rd or 4th grade, you might begin to talk about equivalent fractions and show that although I don't have the same number of pieces, each one of these for that one whole. So this would be my one whole. This is my whole rectangle. For that one whole, 1/3 is blue and 2/3 is red. For this one whole, this is my rectangle. Even though it's a square, it's still a rectangle. For that one whole, 1/3 is blue and 2/3 are red. So there we also get to the idea of one whole. So when you're talking about fractions, you always have to establish, well, what is my whole, right? Do I have a whole pizza that's an individual size pizza, or do I have a whole pizza that's an extra large pizza? And so that's that idea, all right? So we'll end right there for that one. Let's look at the next one. It says, build a triangle that is 2/3 red, 1/9 green, and 2/9 blue. And so I am going to use, and it doesn't say it here, but I'm going to use pattern blocks. And with the pattern blocks, I have these pieces. Let me just show you. I have a yellow hexagon. I have a red trapezoid, a blue rhombus, and a green triangle. And from these pieces, I want to try to figure out how can I get 9ths? How can I get 9ths? Well, I know that if I take 6 of these, I can put them right on top. If I take 6 of the triangles, I can fit that right on top, and you might not be able to see it, but I can fit it right on top of the yellow. And so right now I have 6. So I have 6, like 1, 6, each green. But if I take 3 more of those, then I would have 9ths. And I could say these are my 9ths. So I want to start with 9 of these triangles, and I will count each triangle as 1/9. And then I will try to make a larger triangle that is 2/3 red, 1/9 green, and 2/9 blue. So I'm going to do that, and then I will color it in for you. All right, I have my triangle made. So I have my triangle made. Can you get a picture of that? And then I'm going to, I don't need any yellows. So I want part of it to be blue. And part of it to be red. Okay, all right, so this is where I think, this is what I think I'm gonna have. Okay. All right, so let's see. I don't know if I'm right. Okay. So 2/9 blue, let's see. 1, 2, 3, 4, 5. 6, hold on one second. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. So that's 4/9. So that's not right because I only need 2/9. So I need 2/9. So maybe I need another red. So the fun part about this is, okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the reason why I'm counting like that is if I look at my red piece, it takes 3 of the green pieces. And if each green piece is a 9th, 1, 2, 3, so that's 3/9 right there. So if I have 2 reds, I have 3/9, and 3/9 is 6/9. But if students would know that they could reduce that. And so I have 1 green, 1 blue, and 2 red. And so I have my triangle that ends up 2/3 red, 1/9 green, and 2/9 blue. Now, what you can do is you can have students come up to the board and then draw the triangle out, okay? And so let's see if I can find 9 of those. I'm going to start with the pencil. So here's my triangle. Let's see. There's my hexagon. Not sure. Oh, I found it. I found one right here. Ah, lovely. All right, here I go. I found one. I'm gonna do it in black. This is called isometric paper, I think. I really like it because I can use it to do my hexagons really nicely. So here's my green. And then my red, I had here. And here. And then my blue, I had here. Now, okay, so this is really interesting because, you know, some students like to draw, some students like to color, some students like the puzzleness of the fractions. And so take all of this into consideration. So one of the things that I will have my students do is I will have them take a look at this and then take a look at this and talk about what was the similarities between the two activities, and then what was the difference between creating fractions from color tiles and creating fractions from pattern blocks. How are they the same? How are they different? You really want students to have a conversation about understanding, why did I choose 9 pieces? Why did I choose 3 pieces over here? You want them to understand that the denominator is going to help you choose the number of pieces you're going to use. I'm either going to choose 9 pieces or 18 pieces, or maybe even 3 pieces that I have to break up, because 3 times 3 is 9. So they have to know some things about multiples and factors of numbers before they begin to do these types of fractions, equivalent fractions.